Welcome to the online lectures for software engineering. In the previous class, we have studied a few models. The two models that we studied were extreme programming and adaptive software development. The two models we have studied. Now, there are total 7 models within the agile process models. We are going to study the remaining models today. The next model is Dsdm, Dynamic System Development Method. Now, this is an agile software development approach that provides a framework for building and maintaining systems which meet tight time constraints. Now, in here, we have studied that extreme programming is used when you've got small to medium sized projects which has got changing requirements. Now, whereas this Dsdm, this dynamic system development method is used when you need to create a particular project within a limited time. That is, you're given a month's time or 2 months or 6 months time. You need to create that project within that limited time. Now, tight time constraints means it is very limited. It can be from 1 to 2 months of time. At that, when you have this type of scenario, you're going to go for DSDM. Now, this DSDM method, it is very similar to the RAD process. Now, if you remember what is RAD, RAD stands for Rapid Application Development. Now, within this rapid application development, one model that we have studied that was called as a spiral model. Now, within the spiral model, what we have done, we are making prototypes for the software that we are going to develop, and then you're every time going to every time going to identify what are the risks. You're going to eliminate the risk, and you're going to again modify the prototype. That is keep on adding features and taking feedback from the customer. The same thing, the same approach is used by DSDM. Now, like extreme programming, ASD, the previous two models that you have studied, they suggest an iterative software process approach. Now, iterative approach means it is a continuous approach. That is, you're going to deliver this, you're going to implement first feature, then you're on top of it, you're going to add another feature. That is an iterative software process, step upon steps. You're going to complete the process within multiple steps. The project will be completed within multiple steps. Now, this DSDM, it makes use of time box scheduling. Now, time box scheduling means now this tight time constraints, that is called as your time box, that you need to deliver the software within the limited time frame. So this is going to make use of time box scheduling. That is, you need to complete the entire project within the specified time that was given by the end user. Now, in here, each and every increment that is in here, we have studied, I have told you that you're going to implement first feature, then another feature. Now, all of these features, individually, these features are going to be time boxed. That is, this feature need to be delivered within some specified time frame. Then the another feature should be delivered within the specified time frame. Now, this DSDM approach, it has got 3 different iterative cycles. You've got the functional model iteration, design and build iteration, and implementation. You've got 3 iterative cycles. These are your iterative cycles. Whereas you're going to have 2 additional life cycle activities, that is going to be feasibility study and business study. Now, we'll first start from the feasibility study. Now, what is going to happen within the feasibility study is you're going to gather the basic requirements of the particular project. Now, when you have the basic requirement of a particular project, you get to know why you're developing the particular software. When you know the basic requirements, you're also going to identify what are the different constraints. What are constraints? Constraints are limitations for the particular project. So what are the constraints that are associated with this requirement that need to build? Now, in here, when you know the basic requirements and the different constraints for the particular project, you're going to identify whether this particular project need to be developed using the DSDM approach. You identify whether this particular project, it is a viable candidate for DSDM. You identify whether it is a viable candidate. If suppose this project requires to be delivered within specified time period, then only it is going to match the feasibility study. That is, you identify in here whether you're going to deliver the software within the limited time frame, whether it meets this requirement, then you are going to start with the project. Then the next one is the business study. Now, as the name says, business study, you're going to identify the different functional requirements and the different information requirements. You identify the two different types of requirements, and in here you're going to identify whether this particular project is going to provide you with the business value. Now in here, the term business value means profit. Now in here, the functions and features that are used within this project, whether they are unique or not. Now if you are developing a particular project that has got all the same features that are already within the market and there are multiple projects associated, then you're just wasting your money and resources for a software to be built that no one is going to buy. So you're going to identify the different functionalities and information requirements, and then you're going to identify whether this particular project is going to provide any business value. And in here, when you identify whether it is going to give you some specific business value, you're going to define the architecture. That is how you're going to develop the project that will be identified. Then coming on to the functional model iteration. Now within this function model iteration, what you're going to do, as you have identified the functional and the information requirements, based on that you're going to design a prototype. Now what is a prototype? Prototype is a model, not exactly the software that you're developing, but a model of the software that you're developing. So in here you're going to build a prototype. Now in here, this prototype is built upon a particular increment. That is, if suppose the first within the first increment you need to deliver some basic functionalities. Now if you're designing a particular project for e-commerce website, so in here you're going to identify basic first. What are you going to identify? Like first, Amazon got started with the Kindle, so the first increment within this will be the Kindle website. So that will be the first requirement. Now in here, this prototype is designed so that you can identify what are the different functionalities that the customer wants, so that you identify the customer's point of view. Now this prototype is developed so that you can gather requirements. That is your functional model iteration. Now when you gather the requirements, now when a prototype is developed, you're going to show this to the end user. Now the end user is going to see this prototype, he's going to perform a few operations, and based on that he is also going to provide feedback for this particular prototype, that this whether the features that you're embedding within the software, whether those are the same that the end user has requested. That or if you want any more changes within the particular model, that can also be made within the next prototype. So this is the function model iteration. The next one is design and build iteration. Now within this design and build operation, as within the previous phase, you've seen that we have designed prototype. Now this prototype is going to have all the requirements from the end user, and you're also going to have the different feedbacks from the customer. So in here, you're going to revisit the prototype to identify whether all the functionalities that were told by the customer, whether all of them are present within the main software that you're developing, whether all the feedback that were given by the end user, whether all of them are present or not. This is going to be identified within the design and build iteration. Now in here, for some projects, this design and build operation and functional model operation, they are going to occur concurrently. That is, you're going to design a prototype. Now based on that prototype, as a prototype is being built, you gather the feedback. Those changes will be made concurrently in the main software. So for some projects, this is going to happen concurrently, or else it is going to happen first the function model iteration is going to take place, then the design and build iteration is going to take place. Then the next one is the last iterative cycle is implementation. Now within this implementation, now as you're developing this prototypes, now in here, the multiple increments that you're providing, those are not 100% complete. You know that they are not 100% complete. Now, based upon that also, even if it is not complete, if any changes are requested by the end user, those changes need to be embedded within the software that you're designing. But you can add these changes within the next increment, the next delivery that you're going to give. You can add those changes within the software. Now, within the implementation, it also means that the latest prototype that you have developed, that is going to be embedded within the software. Latest prototype means the latest feature that you have delivered to the end user, that is going to be embedded within the life cycle of the project. That is in here, every time you're adding one prototype, now in here, first prototype was developed. So that is going to be added within the main software. Then the next prototype that you're developing, that will be added. Then the last prototype that you've developed, everything is going to be embedded within the software. It is like you're installing updates for a particular application. Now this Dsdm approach can be used along with extreme programming. You can use extreme programming plus Dsdm. Combining this extreme programming and Dsdm, it becomes a solid process model. So this is the Dsdm Agile process model. The next model is Scrum. Now this particular Agile model, it was developed by Jeff Sutherland. This person has designed this particular Scrum model. Now this Scrum is also going to have some specific principles that need to be followed while you're following the Scrum Agile methodology. Now these principles are similar with the Agile manifesto. The 12 principles that we have studied for the Agile process model, you've got a few similar ones within the Scrum. So in here, small working teams are organized when you're working with Scrum. Now you can have multiple teams if you're working on a large project, but in here the team size is going to be small. The next one is the process must be adaptable to both technical and business changes. Now in here, we know that Agile means you can make as many changes you want based upon the requirements, technology, and people. Now in here, within this Scrum methodology, it should be adaptable based on technical. We know in here from the definition of agility, technical changes can be made. Whereas within this, you should be able to make any business changes also. Now business changes means if suppose adding some specific functionality is affecting the market, that is, it is going to increase the sales of the particular project, then you're going to make those changes within the model so that it gives you more profit. The next principle is the process yields frequent software increments, like the previous models that we have studied, like extreme programming, Dsdm, all of the software that are built using these technologies, these have frequent software increment. That is, every time each feature or each functionality is delivered in increments. You're not going to have the complete software in hand. You're going to have multiple features within hand. That is, first you can have some basic features, then upon that you can have more features. Then constant testing and documentation is performed as the product is built. Now in here, we know that the software is being delivered in multiple increments, but even if you're developing the software in multiple increments, for each increment that is going to be deployed to the customer, these need to be performed testing. Like these different increments should not be delivered without performing testing. That is, whatever you're delivering, it should be the best that is being developed. It should not have any bugs within the software. It should not have any errors. It should be accurate. That is why you're going to perform testing. And documentation should also be done. Now, why we are performing documentation? Why we are making a documentation? We are making the documentation so that you identify what are the what were the requirements, then next what were the changes requested. Each of the things in here you have in written. That is how many changes were there. Each and everything is documented so that at the end you can tell the end user how many changes were there, so that you can identify, or you can say that why if suppose a major change was embedded within the software. Now this major change is going to require a lot of time. So in here you need to convince the end user that this particular increment needs some more amount of time, because in here the basic requirements was something else and the changes that you made is a completely different. So in here this documentation is very necessary. Then the last Scrum principle is Scrum process provides the ability to declare a product done whenever required. Now in here, whenever you're using the Scrum Agile method, now in here, this Scrum process has the ability to declare a product done whenever required. That is in here, suppose the end user is going to come and tell you, I want this update also, this also. Now that those can be small meaningless updates. So this Scrum process, like the team that is working on this particular process, if they say that the process, that this particular product is being completed, that is no more changes can be added. If now at a certain amount of time, adding changes within the software, it can complicate the software, or it is going to increase the cost that the customer is not satisfied to pay. So in here, the Scrum process can say that the product is done whenever required. Now the Scrum methodology, it emphasizes the use of a set of software process patterns that have proven effectiveness for projects with tight timelines. There's a summary of the software that we're studying. Now in here, you're going to identify the few activities and tasks that you're going to follow for developing the particular project. And in here, like Dsdm, within Dsdm, this project was used for limited tight time constraints. Whereas Scrum is also used for limited time constraints. And when you've got changing requirements within the software and the business is very critical. So in here within Dsdm, it was used only for tight time constraints, whereas Scrum is used for tight time constraints, and you've got multiple changing requirements, and then business criticality. Now in here, as you have stated that within the Scrum principle, it stated that the product that you're developing, it should be adaptable to changes within the technology as well as within the business. Now within the business, it can also affect the different policies that the business has. If you have to change the two things also, you should be able to do, whereas this particular thing was not available within the Dsdm. So when you've got a project that requires changes within technology as well as the business along with the tight time constraints, you go for the Scrum Agile method. Now in here, the framework activities that are used are requirements. First, you're going to gather the requirements, then analysis. You're going to identify the risks that are associated with the software. You're going to do the coding part, designing or making the architecture, then evolution, that is you can design the different prototypes, or you're going to do the testing part and then deliver the product to the end user. Now in here, when you are developing each and every framework activity, you're going to perform the different work tasks. Now these work tasks are carried out by a process pattern that is called as sprint. Now in here, we have studied that it is going to follow a process pattern. This process pattern is called as sprint. The process pattern in here is called as sprint. Now what is sprint? Sprint is a work unit, that is, you can say, a set of people that are going to work on a specific requirement. Sprint is a team that is going to work on a specific work unit. Now I'm going to tell within detail the different terms that are used within the Scrum Agile method. Now in here, we have studied that the process pattern that you're following in here is called as sprint, is the process pattern that you're using in here. Now within this each process pattern is going to define a set of development tasks and allow the Scrum team to construct a process that is adaptable to the needs of the project. Now what are these development tasks that the sprint is going to follow? The first one is called as backlog. Now this backlog is called as the list of project requirements. That is all the requirements that were stated by the end user. The different features are going to be stored within the backlog. Now these different requirements, these are going to tell you what is the business value for the customer. That is embedding some specific requirement that is unique, that is going to give him so much amount of profit. that is going to be identified. Now in here, within this backlog, you're going to have a list of different project requirements. Now the question arises, who is going to access this project requirements? The person that is given access to this list of project requirements is called as the product manager. The product manager can access the list of requirements. Now in here, this product manager has got access so that he can update or make any changes within the list of requirements. Now in here, this product manager can update the list, or he can prioritize some specific requirement. That is, changes in here are done only by the product manager. This list cannot be accessed by any other persons like the developers or the coding people. The next one is sprint. Now in this sprint, we have already discussed what is sprint. Sprint is a process pattern. Now in here, this sprint is going to consist of different work units. Now as you have seen that within the first slide of sprint, we have identified that sprint is going to have small teams. Now those small teams can be called as work units. Now these work units are required to achieve a specific requirement that is listed within the backlog. Now this list of requirements, within this list of requirement, the sprint team is going to access one specific requirement, and based on that, they are going to do the task so that the particular requirement is completed. Now if you're developing an e-commerce website and you want to add an additional column for, suppose, different types of shoes, the different types of shoes, you want to add another brand of shoes or anything. So that particular requirement, based on that particular requirement, the sprint team is going to work so that that particular feature is being added within the particular software. Now this feature needs to be delivered within a specified time frame, or we can say that this is called as the time box. Now time box means you're delivering the software within a specified time period. Now in here, another thing to be remembered within the sprint is that whenever you are working within the sprint, so in here, within this, when you are working on the sprint, this backlog and the different sprint items, that is what feature that you're working on, these are going to be frozen. Now frozen means when you're working on a particular requirement, you cannot go for any changes. No changes are there when you're working on that particular requirement. The next one is Scrum meetings. Now these, within the Scrum meetings are called as short meetings that will be held by the process pattern Scrum, or you can say the Scrum manager is going to host these meetings. And within these meetings, the Scrum manager is going to ask a few questions that need to be answered by the team members, the people that are working on them. The team members need to answer a set of questions. Now I'll be telling what are the different questions within the next slide. Now there's the diagram of Scrum. Now within the first stage, this is the first stage. You're going to have, from the customer, you're going to take the different inputs from the end user, customer, team, and other stakeholders. Now in here, the different inputs are going to be taken from the end user, the people that are going to use the software. Customer in here, the one who is developing the software. Now in here, the team and other stakeholders. Now whenever you're designing a particular software, in here you're going to have different stakeholders. That is, you're going to have the different managers, you're going to have the marketing people. Now all of these people are going to be benefited by the development of the particular software. So in here, based upon each and everyone's profit, you're going to take the input. That is, in here, the managers and the marketing people want new features within software so that they can sell them very fast. So the input is gathered from all the different stakeholders, team, and the end users. Now all of these features are collected by the product owner. Now this product owner is going to have a list of features. Now within this list of features is called as product backlog. Now as you've studied what is product backlog, it is going to be a list of features And this list of features can be accessed only by the product manager. Now this product manager, what he can do, he can update this list, or he can prioritize any specific requirement. Now this Scrum methodology, it can also be used when you have got a priority, that is, I want this specific functionality to be developed, to be delivered within that specific time frame. Then you go for the Scrum. So in here, this product manager has got access that he can make any changes within the product backlog. Now from this product backlog plan, you're going to make a plan of how much work you're going to do, and you're going to commit for the sprint. Now in here, this task is going to be done by the team members that are going to do the coding part, the designing part, the testing part. These people are going to identify what work each team needs to do. That is, this is a small working team. Now in here, you make a sprint planning meeting. Then within the sprint backlog, we have identified that in here, what you're going to do, you're going to take one specific requirement, and based on that specific requirement, you are going to deliver that specific feature in a time box. That is, within that specific time frame, you're going to design that particular feature. Now, when you're within the sprint backlog, the product backlog is going to be frozen. That is, no changes are accepted when you're performing the sprint backlog. Now, in here, when you have identified the different tasks and you're working on that, now it is written in here, no changes during the scope of the sprint cycle. Until this entire thing is completed, you're not going to make any changes in here. Now in here, while you're developing the particular software, now in here, you're going to perform the different sprint meetings. Now in here, the sprint meeting is going to be every 24 hours, and the entire software, if suppose it is going to take the time for 2 to 4 weeks, so in here, within each and every day, you're going to have Scrum meetings. Now in here, within the Scrum meetings, the Scrum Master is going to hold this Scrum meetings. Now this Scrum Master is going to ask a few questions. Now in here, those questions can be, the first question is, what did you do since the last meeting? Now this question is chosen so that you identify what is the amount of work that is done by each member. The second question is, what are the different obstacles that you are encountering? Now in here, if suppose the first question is that what did you do since the last meeting? If the answer is that you have not done anything, so in here, now why have you not done anything? It can be because due to some specific risk or some specific obstacles. So these obstacles are going to be identified within the Scrum meeting. Now when you identify what is the obstacle, you're going to identify what is your plan by the next meeting. Now, as you identify what are the different obstacles, how you're going to eliminate those obstacles, what are you going to do within the next meeting? Now, basically, you're going to try and reduce the risk, and you're going to start developing the software, add on the different features. Now, in here, by the end, you're going to have a potentially shippable product increment. Now, this potentially shippable product increment means in here, one specific feature is being completed, and that can be delivered. Now in here, you also got this retrospective. Now what is this retrospective? Now a retrospective, it is also a meeting that is held after the product is being shipped. Now in here, you've got a shippable product that is a completed project. Now when you've completed the particular product, you're going to have a meeting that is called as retrospective. Now within this, you're going to identify how you have delivered the particular product. What was the release process? What was the goal? How did you deliver each increment, and any future plans or any updates that are going to be discussed within the retrospective meeting. So this is the Scrum Agile process model. What happens within the Scrum model? All the inputs are collected by the product manager. Now those inputs can be from the end user, the customer, the different stakeholders. Based on that, you're going to make a product backlog. From the product backlog, the team is going to access one specific feature at a time, and they are going to start working on that. Now, while you're working on a specific feature, no changes can be done while the work is being done. Now, as the work is being done for specific different tasks, you're going to conduct different sprint meetings. Within the sprint meetings, the Scrum Master is going to ask specific questions to the team members. That is, what was done from the last meeting, what are the different obstacles that you're encountering, what are you going to accomplish by the next meeting. This all is going to be identified. Now in here, as the sprint meeting is completed by from 2 to 4 weeks of time, you are going to deliver that particular increment to the end user. As you're delivered the particular increment, you're going to again establish a meeting that is called as a retrospective, where you're going to identify what was the goal, how did you plan the different cycles, and then what is the future plan of the particular product that you delivered. So this ends the Scrum model. Now this Scrum, it is an iterative and incremental agile process. Now we have already discussed that it is iterative as well as incremental method. Now this Scrum is going to incorporate a set of process patterns. Now process pattern that we have discussed is, it is called as the sprint process pattern. We have taken the entire diagram for identifying how you're going to work upon the sprint, how you're going to complete a particular project by making use of the sprint pattern. Now in here, you're going to, now within this, what are the different things that you're going to focus on? Now within the diagram that we have not discussed, that is the project priorities. Now in here, as we have discussed, that the product manager has got access to the backlog where he can prioritize any requirement. That is, you need to deliver this specific requirement. That was basically first when you've added the requirements, it was not prioritized, but at the later you can prioritize any of the requirement from the backlog. Then compartmentalized work units, that is in here, as we have studied that you're going to have small teams. Now these small teams, you can have multiple of these small teams that are going to be compartmentalized. So these small teams, they are going to work individually. That is, one feature is going to be accessed by one particular team at a time. Then communication. Now in here, as multiple teams are working upon different features, you need to have effective communication between the different teams. Now in here, why communication is the main theme in here is because at the end, some particular features might be combined. So in order to combine the specific features, you need to identify at what pace they are working, whether the particular product will be completed within the specified time frame. Then in here, you're also going to collect frequent customer feedback as you're developing the software in an incremental agile method. Now in here, as you're delivering one feature at a time, you're also going to take feedback from the customer. Now from this feedback, you can either make changes within the software or how you're going to optimize the software. That is going to be identified.